Hi, everyone. Welcome to today's webinar. My name is Betsy Ames. I'm the Executive Director for the Northeast HERS Alliance, and we're delighted to have you with us today for our webinar with TimberHP on high-performance, low-carbon wood fiber insulation. Thank you for taking time to be here today, and a special thank you to Allison, Ken, and Jason of TimberHP for speaking today, and also to Emily Anderson, the Northeast HERS Administrative Assistant, for running the technical aspects of the program today. In today's webinar, we will be talking with TimberHP about how they are evolving energy codes, building standards, and green building reporting requirements connected to permitting and incentive programs. All of the above is driving demand for low carbon, high performance materials across the Northeast. Building professionals are under increasing pressure to deliver solutions that meet these stringent standards without adding unnecessary cost or complexity. This session explores how wood fiber insulation meets these stringent requirements, offering carbon storing and energy efficient performance naturally, while delivering exceptional thermal, acoustic, and vapor managing performance. This session will include both presentation and a time for question and answers. And actually, if you have questions during the presentation, please put them in the questions panel. We will ask questions as we go and at the end. But before we begin, we do have a couple of announcements. Our upcoming HERS Rater training for, mentorship program. First, our upcoming summer 2026 Rating Field Inspector and HERS Modeler mentorship program starts on June 29th. We are accepting applications from now until May 4th. If you're interested, you can learn more and apply at the links on the screen or the QR code on the screen. And I'm also going to drop the link for the application into the chat. Our HERS Rater training class is starting July 6th. If you register before June 8th, you'll receive $200 off of your registration. The final deadline is Monday, the 22nd of June. If you're interested, you can learn more and register in the links on the screen or the QR code on the screen, and I will also drop that into the chat for you. We are also very proud to present our latest research on the Massachusetts 100 home embodied carbon study. This study was a product of the collaboration between the Northeast HERS Alliance, Stevens & Company, Ecotrope, Builders for Climate Action, and the NMR Group. And the study was funded generously by Mass CEC, as well as National Grid and Eversource. The primary goals were to explore the feasibility of adding embodied carbon analysis to the typical operational energy assessment conducted on residential buildings by HERS raters, and to use these augmented energy assessments to explore the feasibility of establishing baseline values for embodied carbon emissions generated by residential new construction in Massachusetts. If you'd like to learn more or read the full report, please check out the links or the QR code on the screen. I'm putting that into the chat for you as well. Now, let's go over a few details about today's webinar. It will be about 90 minutes. After our announcements, the main presentation will be about 60 minutes, and then we will take questions as we go and at the end. While the speakers are presenting, please participate in listen-only mode. We will be asking a few poll questions at the very beginning of the presentation, so please take time to select the answer that best reflects your opinion. We do value your input and participation. If you have questions during the session, as I said, please type them into the questions panel, and you will be able to interact with the speakers or me by using that questions pane. We will address them at the end. And if there's not time to address them, we will send them to the speakers to follow up. There will be a moment for questions and discussion time after the presentation. If time doesn't allow us, we will make sure that we get an answer for you from the presenters. If you would like a copy of the slides, please go ahead and download the slide deck from the handouts panel on your dashboard. And if you enjoyed this webinar and want to keep up with the Northeast HERS webinar series, I encourage you to follow us on Facebook and LinkedIn and Instagram. I'm going to drop those links for you also right into the chat right here. And there you go. We appreciate you supporting our work by sharing our posts and distributing our information within your network. Also, as you exit the webinar today, a survey will appear on your screen. So please take a minute to complete this survey so that we can get your feedback on today's program. Your feedback is really important to us so that we can take your responses into consideration with a professional development committee here at Northeast HERS so that we can continue to improve our webinars. And I'm going to share that link also with you so you can see where to go for that. All right, now it is my pleasure to introduce our speakers today. Allison Zuckman is an architecture and green building professional who helps project teams deliver healthy, low-carbon building solutions. As a market intelligence and lead development manager at TimberHP, she supports early-stage project development across New England, bringing relationship-driven insights and a passion for bio-based materials and resilient design. Welcome, Allison.
Thanks. I'm really glad to be here today.
Also speaking today is Ken Kiefer. He brings 25 years of experience in building materials, sales, and construction, and consulting, including leadership roles with high-performance envelope manufacturers. As a strategic account manager at TimberHP, he supports projects from concept through installation with a focus on specifications, training, and affordable housing. Ken is passionate about workforce education and U.S. manufacturing. Welcome, Ken.
Thank you very much, Betsy. Glad to be here.
Great, thanks for being here. And last but not least is Jason Todd. Jason is the Director of Building Science at TimberHP. He has over 20 years of experience in the built environment. His passion for building science, energy efficiency, and sustainability evolved early on in his career as a contractor, then energy auditor, and then insulation installer. He has held various roles supporting energy efficiency programs, educating contractors, installers, and HVAC professionals with a focus on building science and building envelope best practices. Thanks for being here today, Jason.
Happy to be here. Thank you.
All right. We have a lot to cover, and I'm really excited about this presentation. So let's turn it over to our presenters. Please take it away, TimberHP.
All right. Thank you so much. So yeah, let's talk a little bit about some of the wonderful world of wood fiber insulation. If we can go on to slide 11. So we'll start by giving you a little bit of a heads up, an overview of what TimberHP is, if you don't already know us. We'll move on and talk about what our current insulation market looks like. Then we'll hit the wood fiber insulation performance advantages, and then move on to the embodied carbon and wood fiber insulation, how they pair really well together. Next slide, please. All right, time for some poll questions.
All right, so the first poll question should be appearing on your screen, and I'm going to read this out in case there are folks attending on the phone who can't see the screen. So the first poll question is, who's on the call today? Are you a HERS rater, an architect, a builder, an owner, developer, or a consultant or engineer? So please take a moment and clock in your answer, and we can go ahead and close that poll and show the results, please. Great, so HERS rater came in at 25%, architect was 0, builder is 11, owner developer is 13, and consultant engineer is 50%. Allison, do you have any comments on this before we jump into the next poll?
No, it's great. It's great to see a good mix. I think we're just curious to know who's on the call so we can speak more to each of you. So it's great to know. We figured there'd be HERS raters and consultants based on who's involved in this organization, certainly.
Yeah, you guessed right. Great. All right, let's have the next poll, please. So the second poll is, have you used wood fiber insulation in your project? You have two choices, yes or no. So please take a moment and log in your answer. And we will leave this up here for a minute so you have a second to put it in. I'm very curious to see what the answers will be here. So we're just going to leave it here for another second. So go ahead and take it down. Great. So the answers were yes, 25%, and no, 75%. Allison, any comments on this one?
Well, I think it probably makes sense, since we are the first manufacturer of wood fiber insulation in North America, that only 25% have used the product, because we haven't been around that long. But we're also we're glad to make that number a little higher after today, hopefully.
Fantastic. All right, great. Let's see the third poll. All right. The third poll is, when considering insulation, what is the most important quality to you? Performance, thermal and acoustic, durability, moisture and pest resistance, cost, environmental impact, or installation or ease of installation. So please go ahead and log in your answers for this one. We're going to leave this up also for a few seconds here so folks have a chance to click their answer, even if they're in the middle of working on an email or something. We still want to know what you think. So, yep, the answers are coming in. This is good. This is great. This will be very interesting. So we'll just leave it there for a couple more seconds. Performance, durability, cost, environmental impact, or installation or ease of installation are your choices. All right, let's go ahead and see the answers. All right, so performance came in at 57%. Durability came in at 0. Cost came in at 14. Environmental impact came at 29. And ease of installation came in at 0. Allison, any comments on this?
Well, we always get a variety of answers to this question. I think performance, environmental impact, performance and cost, I would say, are always, in any audience, the top considerations. But I'm glad, and we're seeing, we'll talk more about today, but we are seeing environmental impact, carbon reduction, also just the fact that we're using reclaimed material from the timber industry in Maine, all of those things. We're glad to see that people value environmental impact also, because we feel like we are outstanding in that category compared to other insulation products.
Great. All right, so I'm going to turn this back over to you to jump into the presentation. So please take it away.
All right, perfect. All right, so let's talk a little bit about TimberHP and slide 14. This is an overhead shot of our factory that is now operational since I think 2022. Jason, you can correct me if I'm wrong. That was an old paper mill in Madison, Maine. This is about 600,000 square foot of manufacturing space that is hydropowered. You can see the dam there on the right of your screen. So this gives us just a great opportunity to manufacture using a very, very low carbon footprint for operational energy, and put a lot of those people back to work that were working at the paper mill before. So we're very happy that we were able to provide some economic benefit to the surrounding towns of Madison. On to the next one. And here you can see some shots of our team there on the left. And also, this is where all the magic happens. This is a picture of our bat insulation line, operational, and just making some of the best insulation in the United States. On to 16. And this is important for us because we've in Maine have been devastated by the loss of paper mills There once were 16 to 18 paper mills. We're now down to 2. So we have lost over 4 million, a market for over 4 million tons of low-grade residual wood that the paper mill industry used to use. We're able to source all of our raw materials from different lumber mills and forestry companies from within 100 miles of our mill. And you can see just how much of northern Maine has certified or not certified timberland, but mostly certified timberland, where we can have access to an almost unlimited supply of raw material. I don't think we'll ever, even at full capacity, we'll ever touch more than half of what's available in the market. So we've been able to really help revitalize the whole industry, not just putting the few people back to work that do work for us. On to the next one. Now in Europe, this is a very, very proven and existing technology. They've been using wood fiber insulation for decades there. They have 20 to 25 plants. There's more in development. It's well over $1 billion market. But in Europe, because of the benefits of wood fiber insulation, they're willing to pay the 20% premium that they experience over other types of insulation. That's not the same here. We have more trees than people in Maine. They have more people than trees in Europe. So the raw materials are much more expensive in Europe. So we won't see that same cost premium, which puts us at a real competitive advantage. We can move on now. And if we look at this, just the pure availability of great timberland, great wood baskets all over the country. This really affords us the opportunity to not just manufacture in Maine, but as wood fiber insulation becomes more mainstream, we have opportunities all over the country to utilize a raw material source that, with the decline of paper manufacturing in the United States, would otherwise go to waste. And we know that the only way to turn a tree from a carbon storing entity to a carbon releasing entity is to let it die and rot or to burn it. So we want to bookend the country. We want to grow and really store the carbon for the trees long term and really help out our country from a embodied carbon standpoint and from an economic standpoint.
Yeah, Ken, I think that's it's worth restating the abundance of the residuals and how we have shifted away from paper and other products. Even paper mills here are retooling to look at brown stock and cardboard, but there's just an overabundance of the raw materials, and everywhere you're seeing green here is well-established timberland, and they have a residuals problem. We get that objection from folks about, well, you're going to run out of material or you're going to cut down a lot of trees. But you can see just here in the US, and certainly it's even darker green to the north, there's plenty of materials when you talk about the residuals market in the US.
Yes, absolutely. And that's it's important from an economic standpoint, because forestry is an expensive undertaking, and is a dangerous undertaking, and while losing economic drivers to maintain some of those, to offset some of those costs and danger, the forestry industry at large faces hardship without a market for their residual materials. So it's very important for sure. On to 19. So this is a very quick and simple diagram of how wood fiber insulation is made. I mean, we cut down trees to make square or rectangular boards to build our homes, and we know we need a lot more homes where we have a housing shortage. So we're going to keep harvesting trees in a sustainable way by replanting them, but When we cut a round log into rectilinear shapes, we get waste. We take that waste, we take those wood chips from the lumber mills, and we run them through our refining process. That refining process, though it looks complex when you see the images of the manufacturing equipment, it's relatively simple. We steam the wood, we get it to a certain moisture content, we grind down the wood chips into a very specific fiber size that we need. We have very highly engineered plates that grind these wood chips into the fibers that we need. Once we get them into the fiber, then we can then spray them with a liquid solution of borate salts for our fill and bat product. Those borate salts are a natural fire retardant, pest repellent. They do a really, really wonderful job at mitigating both of those problems. That is a liquid applied for a reason. Other borate treated insulation products are usually powder treated. So that powder, when they get installed, can flake off and remove itself from the material. We want to put this in a liquid fashion so that the borate stays attached to the fibers. So once the borate is impregnated into the fibers, then that becomes our loose fill insulation or our dense back insulation. It's a very, very simple process for that. To get to our bat insulation, we add a bicomponent polyester fiber, and that will bind the wood fibers together when we bake that in the oven. And that oven only gets up to about 300 degrees Fahrenheit, and really not even hot enough to bake a cake. And then to get the board, we take our wood fibers and we add an MDI glue and a paraffin wax into the fiber, not onto the surface, into the fiber, so that all of the moisture mitigation, all of the adhesive properties are through the board, and then we press it and shape it into our 4x8 formats. So it's a very complex looking machine, but this process overall is quite simple. There is a ton more science that Jason knows really, really well about wood species types, fiber size, glue mix, paraffin mix, and all those good things. So if you ever really want the in-depth story on how wood fiber insulation is made, please feel free to reach out. We're happy to explore that with you. On to slide 20. And as I mentioned, these are the three products that we make. We have our timber fill, we have our timber bat, and our timber board. On to 21. Now, I mentioned earlier that Europeans pay a 20% premium for their wood fiber insulation because of the abundant availability of raw materials. We get those raw materials very inexpensively. So that allows us to be very cost competitive. So for any other borate treated cellulose insulation type, we're going to be comparable in cost to those. For board insulation, we're going to be roughly the same cost as foam. Foam is priced based on the petroleum market. So right now they're facing some price pressures. Mineral wool, we're going to be, we aim to be around 20% less than mineral wool materials for our wood fiber board. Our bat is going to live right in between your low-grade fiberglasses and your mineral wools. We should be priced probably around the same as high-density fiberglasses, but yes, we're going to live right there in the middle of the insulation cost world for our bat product.
The board pricing is comparable by our value too. I think it's worth qualifying. Like the foam board square foot price would be what we're competing at is just that equivalent R value. So we're at 1.5 inches versus 1 inch, and we'll most likely never compete with conventional fiberglass. Certainly a higher density acoustic gets a little bit tighter. But you know that I think what's really important with the BAT product and why it is a premium over that commodity product is just how well it can install and getting a grade 1 install simply because of that the firmness of the material.
Yes, Jason, I like your analogy the last time we discussed. It's a grade 1 install every time.
That's right.
All right, on to 22. So this is us. We're a carbon storing insulation product. We're scalable. There are other carbon storing insulation products available, but they're not as easily to scale at mass. Cost effective, we just talked about that. Carbon negative, for sure. We're turning trees into something. We're not letting them rot or burn. High performance. It's a very dense insulation type, so it will help manage airflow through the assembly. Wood is great at managing moisture. It's what it does to stay alive. So from a cellular structure, it does great at capillary movement of moisture through itself. And then its vapor permeability allows it to dry quickly. Conductivity, we'll talk a little bit about the thermal mass that is uniquely a part of wood fiber insulation. And then sound attenuation, wood fiber insulation, because of its density, is among the best sound attenuation insulation materials available. This is, again, made from wood residuals. So it's very nice to work with. When you cut it, you don't get little foam dust that static clings to everything and blows all over the place. You get sawdust. It's non-toxic and safe. It leads to a really, really high indoor air quality. We don't see any off-gassing of harmful chemicals like you would with other insulation types. And our interior products are Class A flame spread because of the addition of the borate salts. And our exterior board is currently a Class B flame spread because we do not have that borate in there at this moment.
Yeah, really focused on above grade solutions. You know, I think that when you talk about mineral fiber, there's some real high temperature applications where it makes sense, and that's appropriate. When you talk about foam plastics, there's moisture resistance for days. It's pretty inert. And so there's the right place, the right time for the right material. And but we really can solve all of these above grade applications as part of a system, and very conventional framing too. I think that's an important thing when we talk about bio-based materials as well. Love all of the different agricultural based materials out there that are coming on the market. Scalability, performance, price point, and just familiarity with that application. And I think that's one of the things that we are able to offer with wood fiber insulation.
Beautiful. All right. So for those of you that don't know, the HP in TimberHP stands for high performance, healthy planet, healthy people. We perform really, really well from an R value standpoint, a heat absorption standpoint. The R values are stable even in cold weather and over time. Healthy planet, we're recyclable. We do recycle. So when we get the first little bit off the line where it's not quite up to speed because the line's just starting, we can run that right through right back through the manufacturing process. It's renewable. The trees, we can plant new ones. It's non-toxic. Healthy people, it's going to manage moisture, help avoid mold growth, rot. It's safe, it's sound absorbing. So even from the standpoint of building buildings in a city, it's going to be really, it's going to allow people to be really comfortable in their homes.
You know, we find from the early investors and the folks that started TimberHP and got us going, that this sort of three-legged stool, our foundation, the flexibility of it, I think, is really critical, and we try and lead with any one of these or all. It may be that the performance aspects or attributes are what are foremost, or maybe there is more of a focus on people or planet. But in the end, it's all of them for us. but like a mix of interest in a wall cavity insulation or whatever that might be, insulation products in general, performance is paramount for some. Environmental might be the thing that leads for others. So there's a great deal of flexibility, but we feel like this is what gets us into the mass market, and in the end, what the end user or receiver of this material would be looking for. It's going to change a little bit, but we've got multiple answers, I think, to that solution.
Absolutely, absolutely. And to slide 24. So here's what our current insulation market is going to look like. Next slide. We know that every year or every 3 years through the code cycle that we're requiring more insulation to the exterior of the building. We're requiring higher air tightness, all driven toward making buildings more efficient and more durable and resilient. Next slide, please. And to do that, historically, fiberglass has been the answer. It's very inexpensive. It still occupies the largest share of the insulation market at over 55%. And of course, as our values have been driven up by code, a lot of people have turned to foam plastics as an easy way to try and get there. I mean, they have, as Jason said, they have places in insulating, but they do have their own drawbacks. Mineral wool nationally is around 4%. I think in the Northeast we'll see that higher, closer to 10 to 12%, as an alternative to your fiberglass and foam plastics. The rest of the 4%, that's where we fit in with denim products, sheep's wool, all the other bio-based products, cellulose, and things like that. So we can see that we have plenty of room to make hay in the insulation market. Next slide. So as codes have increased in stringency, and building science has provided a lot more data on how we should be building buildings, we can see that we haven't had much change in the insulation industry. Fiberglass has been around since 1938. Most of them are formaldehyde free now, but they're not very dense. They do face easy compressibility for reduced R value. It's easy to not get tight installs and can allow for wind washing in the cavity. We got foam plastics in the 1950s. Foam plastics are definitely flammable and can often have toxic off-gassing. I know I have a friend of mine who's a firefighter in Massachusetts, and this is something that they're concerned with when they enter a burning building. Those foam drips can actually burn through different parts of their fire protection equipment. So that is something that is concerning for them, not only for that, but for the toxicity of the smoke as it's burning. Mineral wool came around in 1953. Obviously, you can't burn a rock, so it is extremely flame retardant. But it's also very itchy. It can be a very big irritant on your skin, and also in your lungs and in your eyes. And then we have cellulose in the 50s as well. Cellulose is definitely falling stock or falling victim to a shrinking feedstock, as we don't use newspapers anymore so much. We're getting all our information digitally. So we see that the feedstock is shrinking. The powdered flame retardant, as I said earlier, that likes to blow off as you're blowing the insulation in, and creates it's a very messy, dusty install. And then we've got recycled denim. It's more of a niche product. We know that there are some companies trying to make it a little bit more mainstream, but there's very little feedstock to that.
Yeah, I think what's something that recently, kind of looking at this slide again, Ken, what's really interesting are the dates of these materials. And from the 40s into the 50s, we're seeing this shift of, improvements in better living through chemistry. And for good reasons, there were some performance advantages based on what was available on the market. Ironically, it's a little bit of a inappropriate to say we're, this new technology 20 years over in Europe. A lot of wood products manufacturers had residuals back in the day, turn of the century, 1900 even, and they were producing a wet process wood fiber board, very dense, not a great insulator, but a pretty sturdy panel. Was a plaster base, and you might find that in looking at older homes. But there was also a bat on the product on the market. And ironically, I don't think they quite understood the whole systems of buildings at the time. And so it was maybe an inch or two thick, and they left airspace to add insulation. Ironically, that caused a lot more wind washing and other concerns and issues. But trying to solve this through some better chemistry, I think there were some liabilities along the way. And it's really kind of interesting to come back around and come full circle at this point, well over 100 years later in some cases, with better performing products that still make a lot of sense within the built environment as we know it. We frame with wood, sheathe, clad side, all of these things, and there's residuals because of that. Like you said earlier, there's some really compelling reasons why, when we look at the house as a system and assemblies as systems, that those products that we've forgotten about, might be as good or not, if not better, than some of the offerings that have some attributes that seem to perform better, but also some liabilities along the way.
Absolutely, for sure. On to slide 28. So as we mentioned earlier, our above grade system allows us to hit all of the energy codes that are already here and that are coming down the pipe. Next slide, please. And one of the best ways we can do this is through the reduction of thermal bridging with the use of the continuous insulation. This is why this has been getting added to the codes, as you all know. This is the best way to maintain your wall's effective R value. I see it all the time. I live in New Hampshire. New Hampshire seems to be the black hole for building performance. So I can go down my street any given day on a frosty or dewy morning and see where every home studs are, just based on the melt pattern of that frost. Next slide. So this is just a quick slide based on our climate zones and what is required for wood and metal framed commercial and residential construction types for interior and exterior insulation. Next slide. So for us, we look at ourselves as a relatively drop-in replacement for most above grade materials. So we're going to see the easiest replacement, especially in the bat, because this is going to install exactly the way your mineral wool bats are going to install. You're going to get a grade 1 installation every time. You're not going to be able to just grab handfuls of it like you will with fiberglass, for sure. But the installation quality will be much higher. Attic blankets are going to install relatively the same as your cellulose. The machine just needs to be adjusted properly, and we do have guidance on how to adjust the machine properly to blow a denser fiber. And then our board insulation, any contractor who's ever cut a piece of sheathing should be able to use our board insulation very easily. Cuts just like wood with all the same tools that they have, and it compresses very, very little. So the final cladding is going to have a higher quality install because of that. Next slide, please. So for our exterior board insulation, we're going to say right now with our Class B rating, we're going to be able to be used in single and multifamily construction types, type 5B most specifically. So buildings 4 stories or less, some mass timber, CLT, and then of course this is a great addition to factory-built solutions for either panel or modular buildings, and of course passive house and net zero carbon negative buildings were the perfect fit for all of those as well.
Yeah,
Next.
you're seeing some outside of the traditional residential type 5 construction, but for the cavity insulations in particular, it's something that's available for any construction type. We've got hourly rated walls and acoustic STC ratings on walls as well for those cavity insulations. So it's something to consider when projects go beyond the residential scope.
Absolutely. Absolutely. All right, now we can go to number 33. So wood fiber insulation performance advantages. This is actually for any of you who are near South Boston. This is in Roxbury at 27 Kenilworth Street, if you want to go see it. Next slide, please. So our loose fill and dense pack insulation is going to get an average of our 3.8 per inch. Jason, that's a little bit lower for the loose fill, correct? 3.7 maybe?
Yeah, when we get dense packed, we'll hit that 3.8 per inch, but it does drop depending on, like, if it's in an attic. There's sort of a progressive density, so it's all in a number of inches to hit an R value. So 3.4, 3.5, 3.6, depending on how compressed it gets. It gets better to a point. We get up towards the bat density. That's sort of where we tap out or maximize our R value per inch.
Perfect. And as Jason said, this is treated with our borate salt. So this is Class A and can be used in nearly any construction type. Next slide, please. In our bat insulation, we have this for wood and non-structural steel framing for 16 and 24 on center. And you see the size, the thicknesses listed here. This is going to be an R4 per inch, very vapor open. It is flexible, but still semi-rigid. It is not as compressible. So when we see, the grade 1 install, where you lose a little bit of quality of install is when people just kind of mash it into the cavity and don't fluff it back out. We don't have that problem. Of course, no toxins or harmful fibers. And again, this is a Class A product, so it can be used in nearly every construction type, and it is really, really good at demising walls and sound attenuation. Next slide, please. And here is a video of the proof of concept of the fact that, yes, it is a loose wood fiber product, but it will not burn because of the addition of our borate salts.
You can see that it's a direct flame applied to the bat product. You get this charring on the surface. You can see a little bit of glowing there. But I think the important thing and the most notable thing, even with this lighter, airy product, is that it's not sustaining flame. That there's very little smolder. There's some smoke coming off of this. We get really solid performance because of the borates that are added to it, but also because of that charring effect. The wood fiber shuts down added oxygen, fueling that flame.
Yeah, this is that's a big an important point. It's a twofold process for that flame resistance. If we look to what happened at the Cathedral of Notre Dame, the biggest reason that there wasn't more catastrophic damage than there was is because the char protected the wood. One of my colleagues, John Rockwell, has a story that during his time at Wentworth, they showed a picture of a old mill building that had caught fire, and there was a melted steel beam laying over top of an intact wood beam that was charred but still protected and holding up the now failed steel. So wood naturally, a solid wood is naturally difficult to burn. And we take advantage of that and then increase it with the addition of the borate salts. And now we have our continuous board insulation. This is going to be a stable 3.4 to 3.7 per inch. We say that because other insulation types lose R value as it gets colder. Insulations are, the R value is measured at 75 degrees, and we can lose a significant portion of the R value with other insulation types as it gets colder and as they age, especially with foamed plastics. As they age, the cellular structure of that foam breaks down, off gases, and you will see a degradation in R value performance over time. The material is hydrophobic. Like I said, we treat it with a paraffin wax. So no matter where you cut on the board, that edge will also be hydrophobic. It's vapor open, it's wood. It does a really, really great job at buffering moisture. And then also buffers changes in humidity and temperature. And that's a really important topic that we'll talk about here shortly. Next slide. And here is a demonstration of just how well it will beat up and get rid of bulk moisture.
So we have a combination of resin binder holding the board together, but also have added paraffins. So small percentage of the board composition. You can see at the top where the water's pouring down, it's starting to maybe wet out a little bit, but we can run this all day long and it's never going to make its way through the bulk of the board. It's hydrophobic, particularly at the surface, but also it's a little bit of a complex puzzle because we're treating it at the fiber level. It remains vapor open and it allows moisture to move around as needed. Acts as a big buffer to the structural sheathing and the structure itself, which is the critical part that needs to stay dry and be allowed to dry in the end.
Beautiful. All right, on to the next one. And here is a video demonstration of our non-borate treated wood fiber continuous insulation compared to our foam counterparts. Just keep in mind during this during the video that it is a non-treated board, so there's no.
Yeah, it's I find this really compelling in the speed of which EPS is not going to be as common on sidewalls necessarily, but it's still it's a liability. And you're seeing even with an XPS foam, even some that are treated, at least at the surface level, to be Class A, to be part of those taller assemblies, and it melts in the end. And there's quite a bit of smoke that comes off of this. The important thing with fire resistance in building materials is allowing people to have the time to get out of the building, not being consumed by the other toxins that might come off of that. And again, like Ken had suggested, Class B board, limited flame spread, limited smoke. The brave Edith grabbing the panel while it's still on fire there. But really surface charring, protection, added time without added chemicals, just the density of the board and that charring.
And like Jason said, God forbid there's an actual fire, the heat absorption and the charring is going to help the board fare really well, and it's also not going to produce toxic fumes as it's burning because it is just wood. Next slide, please. All right, wood fiber manages moisture. So trees do this really, really well. You know, they live outside and have lived outside for millions of years, and they stay alive by managing moisture. Wood fiber can hold 15% of its weight in moisture without losing any insulating properties. When the board is allowed to get as wet as it can, which is not very wet, because Jason, I believe, University of Maine ran it through a test, and only the first 1/8 inch or so saw 100% absorption.
Yeah, we've got some research that the University of Maine Advanced Structures and Composite Center is soon publishing, but the car wash at the Forest Products Lab in the other Madison in Wisconsin drove 6 inches of rain per hour up against the exterior surface of board, mechanically fastened to a structure with only a simple WRB over the face of it, no siding yet. So replicating the construction cycle. It wet out very, very thin layer at that surface, and then proceeded to dry as soon as the rain's turned off, the sun comes out. And sometimes with reservoir claddings or like brick masonry, the sun comes out, it drives that moisture inwards where it's cooler and drier. There's a little bit of that, but we found with additional sensors through those layers that it was very, very low level, very safe levels, well below any kind of potential for biological growth. And it helped buffer that moisture, that wetting event, and protect the structure overall. And I think that's really critical as we better understand buildings and building science and how things all come together. Having materials that can adapt and adjust to wetting events, whether it's condensation inside or it's a bulk moisture on the exterior, allows that assembly to dry and protect the structure of it. Much like in a fire, water is slower, but the same kind of thing. It's destructive potentially when it's not allowed to actually move on and leave that assembly.
Yeah, I mean, the big important thing here to understand is that the wood can get wet. It's not the wetting process that harms the wood, it's the staying wet. So the ability for our products to dry and dry rapidly really increases the resiliency and durability. Next slide, please. And insulation for all seasons. This is something that is very unique to wood fiber insulation. Wood fiber insulation absorbs heat very slowly over time. Jason, I love your analogy. If you put a rock and a stick outside on a hot sunny day next to each other, and you go up soon afterwards and you touch the rock, you're going to feel it's very hot. It's absorbed all it can, and it will release that heat. That stick will not feel so hot because it's still absorbing heat. This really helps to buffer temperature swings within the building, which is going to be really, really helpful to the mechanical systems, to the energy usage. We can't measure R value until we get the insulation material up to steady state. So it has to absorb all the heat that it can before it starts to transport that heat through it to the other side of the building. And Jason, I believe you said it takes about a day or two for our 1.5 inch board to absorb all the heat before we can start measuring the R value, versus other insulation types are within a couple hours.
Yeah, it's absolutely true. There's a balance of density and heat capacity and also conductivity. And when we do steady state, hot plate, cold plate, what's the R value in that? Every material has to reach that steady state to do R value testing. Foams tend to be light density and tend to pass that heat through pretty quickly, even if they are higher R value. We recently got the pleasure of sending some 9.25 inch board down to a lab for third-party testing, and we got to be the talk of the lab because it took 8 days to reach steady state.
That's fantastic, and this is a good chance for me to plug the fact that Jason, you're a part of you're the head of our webinar, Beyond R Value, because there is more than just R value when considering insulation, even though it seems to be R value is the only thing that we talk about. Now I'll have a QR code at the end of the presentation if you want to sign up for the next Beyond R Value with Jason Todd. Next slide, please. And then opening the indoors, these vapor open assemblies allow structures to breathe and dry. I know sometimes that word can be a little bit contentious in the industry, but breathing from a moisture management standpoint, drying out, I will go on record and say that I believe altruistically that when people say a house needs to breathe, they really mean it needs to dry out. I don't want to believe that anybody really thinks that a house should just leak air through the wall system. But yes, we are very vapor open. We're not going to trap humidity within the home that will lead to mold and mildew and all the respiratory problems that we're seeing become so prevalent lately. And acoustics, the acoustics are amazing with wood fiber insulation. I was at a project just recently on Monday, actually, where they're using all of our materials on the inside and the outside. And there is a elementary school in the backyard where the playground is butting up against the backyard. And the children are outside playing and making a ruckus like they do when they're out playing in large groups. And as soon as I shut the window to the home, and this is before any cladding, before any drywall, so it's just exposed wood fiber insulation to the exterior, sheathing, and a 2x6 wall full of our blown in, a dense packed. Once you shut the window, you could no longer hear the children. So the acoustics are phenomenal. So this is going to be a great option for anybody building next to a school, building next to train tracks, building on busy streets, that just really wants to be able to go in their homes, shut the windows, and decompress without hearing the noise and hustle and bustle of the world around them. Next slide, please. And this is an example of some of the acoustic testing data that you'll be able to find on our website. And you can see that in many cases, with very simple assemblies, we can reach the STC rating required for demising walls in multifamily buildings. Next slide, please. Here is one example of how we can, perform better than mineral wool in this very specific assembly. So this is just 2x6 studs, 16 on center, cavity filled with timber bat, resilient channel on just the source side, and one single layer of 5/8 Type X gypsum on both sides. So we can see that we don't have to add double layers of gypsum. We don't have to add 2 resilient channels. It's a very simple wall assembly, and we're going to outperform others in the same scenario. Next slide, please. And healthy people, I know we've talked about this a few times, but it's wood. It's wood, it's all natural products. It is a pleasure to work with. If you've ever had a chance to get your hands on it, you can touch it with your bare hands and not be itching for days afterwards. There's no concern for any of the skin irritation unless you're allergic to trees. The wood pulp from the trees, very few people are, but this is a really, really great insulation choice for everyone, especially those with respiratory problems. Next slide, please. And this will be an example of where wood fiber is allowed according to building type. And this is for us, for bat and fill, we can hit for sure type 3, 4, and 5. Jason, I'm sure you can speak to there may be some wall assembly types where we can get into type 1 and 2. You'll know more about that than I will.
Yeah, it gets a little complicated, but in the non-combustible types, there's a place for us for thermal, fire resistive assemblies. If they're hourly rated, we have those, and certainly for acoustic applications. It gets more complex when you start talking about outside of the walls, and certainly with our board product, we're focused on type 5 construction. Just about all of that available with timber board currently.
Perfect. Thank you very much.
Hey guys, we've got a question here.
Yes.
So is there a listing for USW in a fire rated assembly between multifamily units using the?
So like a fire separation wall, typically it's an hourly rated wall for each in single family attached, if that's what the question is, and you can clarify and try again. But essentially we do have 2-hour rated walls with both timber bat and timber fill, which would work between units.
Yes, that was what he was referring to. Yep.
Perfect. Yes, we have done all of our fire testing with ICC and our evaluation service report. So we're not currently listed except with some real base things in the UL database, but we have parallel assemblies that we can point towards those familiar UL rated assemblies, and a number of options with 2-hour rated walls with double studs and various gypsum configurations, and look to expand on that library as well.
Great, thank you.
Thank you very much. Next slide. And there you see just a highlight of where we stand. And the next slide will show you a little bit more in depth of what our limitations are on building height. Next slide, please. And so there you see kind of where we know we can play for sure without much complexity with the interior products. Again, the exterior product, we want to stay in that type 5 zone. Next slide. Now, low embodied carbon. This is one of wood fiber's most impressive features, is just how much carbon storing can happen within this type of insulation. Next slide, please. So we know that the CO2 emissions by sector is largely consumed by buildings. 38 or 30-ish% of that is the operational energy, heating, cooling, lights, all the good stuff that we need to exist inside our buildings. And 8.2% of that is from the impact of materials and construction. And this is a big reason why our founders went through everything they went through to get this company up and running, because we understood that, hey, we can do a really great job of saving energy, but if we're doing it with high embodied carbon materials, we're only taking it out of one bucket and putting it in the other. So if we go to the next slide, we'll kind of see how that looks. This is how we do our LCAs. You're all familiar with that. We figure the extraction and transportation of raw materials, manufacture, use of product, and end-of-life treatment. And next slide. And that gets us to this, where we're doing a really wonderful job at mitigating through code and the requirement for more energy efficient buildings, mitigating the operational energy of buildings. But we're doing so with much higher embodied carbon materials. Like I said earlier, when building codes ask for more R value, many people look for the path of least resistance, and the highest R value per inch are high embodied carbon foams. So we're trading natural materials in for plastics and petrochemical based materials, which have a high embodied carbon, and that's not sustainable for us in the long term. Next slide. And so you can see this here, concrete is among the worst offenders in the building industry at a high embodied carbon material. We can see roughly 14 to 33% reduction. There's always going to be a large amount of embodied carbon in the manufacture and transportation of concrete. Insulation is really where we can shine. I mean, with the advent of wood fiber and bio-based insulation materials, we can get rid of all of the embodied carbon within the building insulation at no cost premium, and that's a big important factor right there. There's a lot of pushback from builders and the market saying, hey, these buildings are getting too expensive to build. All these initiatives are creating difficulties. The insulation is going to be no cost premium, and we're going to be able to reduce the embodied carbon of the insulation to a negative number. Next slide, please. And I'm just going to reinforce this here. TimberHP is carbon storing. It's wood. We're taking a tree and turning it into something useful. Next slide, please. And that's what we're showing here. That's what trees do. They bring in CO2. They extract the C from the O2, let the O2 back out in the air to give us nice, fresh, clean air to breathe, and they hold the C. And the only time we're going to see that that be released back out into the world is at the end of the tree's life. That happens slowly, but we can stop it from happening by turning them into something durable, something high performance, and something useful. Next slide, please. And this is available on our website. We've got the environmental product declaration with our LCA for our bat. I believe our fill is coming very soon.
That's right. Yeah, we're right around the corner. Actually, we've just wrapping that up and putting the final touches on it. And for those that are looking for life cycle assessment or EPDs for the timber board, which I think is the most compelling of all of the products, we're going to stand up what they call a pre-EPD. It'll be third-party verified, but it's a limited data set. We have enough information. You need a year's worth of data for the life cycle assessment. And we've gotten across that line for our cavity insulations, but just getting started on the board side. So while we have some good reference numbers from European materials, we're just starting to get into our own now, which is really exciting stuff.
Absolutely. Next slide, please. So our EPDs are cradle to grave. And of course, the A1 through 3 is going to be the biggest portion of the carbon storing story for us for wood fiber insulation. Next slide, please. And this is where we really see this put into like hard numbers. So wood fiber insulation, we save about 20 pounds of CO2 per 100 square feet at R1. So we can see that this is going to be exponentially higher as we get into real building size numbers. Our buildings are usually more than 100 square feet, and we use more than R1 of insulation. So the next slides are going to give you a great overview of what that looks like in practice from an actual wall assembly. So here we have the embodied CO2 of a 1,500 square foot passive house wall assembly. This is going to be 5.5-inch stud bay with 5.5 inches of insulation to the exterior of the building. Advance, please. So on the 2x6 bats, we're going to see wood fiber over 0 is going to save 3,100 pounds of CO2. But the delta between us and a mineral wool insulation is going to be about 5,600 pounds of CO2. It is very energy intensive to turn rocks into fibers. It takes a lot of heat to melt them. So the delta between the two is going to be quite substantial. And then as we get into the exterior of the assembly with the timber board, we're going to see that number is going to be, even though it's still 5.5 inches, that number is going to be quite a bit higher as far as CO2 saved and stored because it's a denser product. So there's more wood fiber in the board insulation. Same with the mineral wool. The mineral wool on the exterior is going to be denser. So you're going to see a lot more material needed for those insulation types. And we're going to have a total savings over mineral wool of a little over 19,000 pounds. And that means our wall for a 1,500 square foot passive house wall assembly compared to mineral wool is going to be nearly 25,000 pounds of stored CO2, which is roughly the equivalent of driving a car for 2.5 years. And this is going to be at a cost savings when compared to mineral wool insulation. Next slide, please. And you all are very well aware of all of the research and all of the talk that's happening in the industry about understanding embodied carbon, understanding the implications of what happens if we don't concern ourselves with embodied carbon. There's just so much available data, so much available research on how important this is to start tackling. Massachusetts is doing a great job at pushing forward these goals and these incentives. I mean, the stretch code gives a bonus 3 points for a net zero insulation, which is very easy to achieve with our materials. Next slide, please. And this is what we're seeing. I mean, the proofs in all of the data, all of the studies. Insulation is one of the highest embodied carbon materials in buildings, especially with the prevalence of foam to try and hit ever increasing insulation R values. And this we can save 684 tons or more by switching to wood fiber insulation. Next slide, please. And here is just some more data. This is Allison. This came from our EPD, correct? This image.
I think some of this is information that is coming from the software itself. Actually, a lot of this is with the beam tool, and so some of that is not in the database yet for us. But I understand that they're going to be adding our materials soon.
That's amazing. Great. All right. Next slide, please. And this slide. Yes, we hope to all of our buildings are being built beyond code, but this slide goes to show just how simple a wall assembly, a carbon storing wall assembly can be with wood fiber insulation. We don't need to do anything spectacular, more complex. Your standard 2x6 wall that any builder knows how to build, plus 1.5 inches of exterior insulation will meet code, provide better performance, and be easy enough for every contractor building a home in our market to achieve all of these goals and all of these requirements. That's the one thing that I try really, really hard to make sure that contractors understand, that we're not asking them to do anything different. We're not asking them to redesign or rethink building complexities. This is a very simple and easy process for them to be able to put these buildings up in a very quick fashion. Next slide, please. And as I mentioned earlier, here is our QR code. Please scan that and register for our upcoming Beyond R Value. We've got some great panelists: Ben Bogie, Connor Malloy, Chris Briley, Holly Mumford, and of course Jason. You'll be there too.
There's so many people on that one that I don't have to talk much. It'll be great.
Lots of the brain trust of high performance will be there. Do we have any questions that we can answer now?
Yeah, at the moment, there's nothing in the questions panel. So folks, if you have questions, this is your chance to type them in the questions pane and we'll get an answer for you. I was curious about the what you said at the very beginning about recycling the content of the forestry wood chips. And I wondered if there's like a benefit. I get that there's a benefit to the foresters and lumber producers. Is there an actual benefit to the forests to have that recycled?
That's a really, really interesting question. I mean, a lot of our first investors were forest products manufacturers, logging association. That was a revenue stream for them that dried up with the paper mills. The byproduct of forestry, I mean, in the end, I think if you let the tree hit the floor and work its way back in, there's certainly a benefit to that. That's the natural cycle of the carbon cycle, of that breaking down of the material and providing nutrients. And but I think within forestry, by selectively harvesting and improving the woodlot overall, sustainable, whether or not it's
that's what
labeled.
I was wondering.
Yeah,
if it like
I think
reduces
that
wildfire chances and things like that by clearing out.
huge. Yeah, and I think when you talk about forestry in the Pacific Northwest, there's no value for the tops, for the windfall, for what is low value material, because it's difficult to get out. So it's an added complexity when you're on the side of a mountain. And that's where we're seeing an increase in forest fires. So whether or not that's a benefit to the forest or the people around it is another question.
Right.
But certainly, yes, I think that there's something compelling about just sustainable forestry management practices and leveraging that, but also providing that economic multiplier when we talk about sustainability and also supporting the local economy.
Yeah, it's great. So I do have a couple questions coming in here. So do you or can you do any accelerated testing for dimensional stability? For example, will boards shrink over the decades?
Yeah, that's a great question as well. And we've got some stuff in the works specific to that, because I know that really matters, especially when we talk about structural sheathing and panels. There's a tolerance, a gap that's often left in some applications because of edge swell and just expansion and contraction. So we're exploring that. It's a different, lighter density material, so the dynamics are different. And also, along with the moisture buffering and that redistribution of moisture, we just have a much more receptive and agile product. So it takes on moisture, but it also moves it around and distributes it and sort of makes it less of a concern overall. So there's less movement and shifting in that. We have tested per the acceptance criteria developed by the Code Council for our product, since we're new and innovative. We have tested a fairly torturous path when it comes to the durability of the board. And I think it, above and beyond, expresses how well this does perform. So cycles of high temperature and low, of steam, of freezing, of super saturation, just drowning the board, and going through that in 6 cycles. And then also a number of weeks with accelerated ultraviolet aging, so the stuff that causes things to break down. And in all of that, we have had very little, if any, mass loss, change in conductivity or thermal value, or any dimensional changes overall. We get a little bit of swelling with moisture on the edges, but hardly perceptible. And once it dries, it's back to its tight square edges overall. So I think it's a very resilient material, and that's due to the binders, the paraffin, but the resins that also hold it together, and its ability just to manage moisture very well. So I think it's very, very shelf stable.
Great, thank you for that. How do you buy your product? I'm on the West Coast in a rural area and struggle to get newer building products.
Well, that we have agreements in place with the buying groups of almost every lumberyard in the country. Now, the board ships pretty readily and pretty easily across North America. The bat and fill, they begin to get a little expensive to ship because we're basically shipping air. So you'll probably be able to get them. They'll be able to call their buying groups for the bat and the fill, but you won't see the same price equivalency that we would out in the East Coast, just because of the trucking costs associated with the materials. But I know New Energy Works in I believe Portland, Oregon, is stocking our board material. So the board material is a lot easier to get a hold of out west.
Yeah, a smattering of providers, certainly multiple channels. But to Ken's point, we are based on the East Coast, so there is shipping in all of that. I think the best way to get a little more information in that is to reach out directly with our inside sales folks at info@timberhp.com. You can find us on the website. Availability, I think there's a map on there as well. I haven't looked recently, but reaching out to just the info is a good place to start if you're not seeing something local. But to Ken's point, if there's a local yard and they're willing to bring stuff in, there's probably a program already in place available to them.
Great. Well, those were all the questions that came in. So last call for any questions that anybody might have. Please feel free to post them in the questions pane. And without seeing those, I guess we'll move into wrapping up the webinar. I know there are a couple other slides after this slide. So just once again, I guess your products, you want to speak to the slide at all?
Yeah, this is just a quick reminder and a plug that all three of our product lines are available now. The board has been the talk of the town for many years, and getting a piece of manufacturing equipment from a factory in Germany, disassembled, shipped, reassembled, and commissioned, especially during COVID, proved to be quite difficult, but it is up and running, fully operational, and producing material very, very regularly. So all three TimberHP products are available at this point.
Great.
And then this is just the thing the lawyers make us put in at the end.
Okay, great. Well, this concludes today's webinar. I would like to thank you all for being here again, and thank you, Allison, Ken, and Jason, for sharing your expertise and insights with us. I'm really glad that you're doing what you're doing. I think it's an amazing thing. And I really would like to appreciate the audience for setting aside time in your busy day to participate. We do know how busy you all are, but we would really appreciate it if you would take a minute to give us your feedback by completing the survey upon exiting the webinar, including any topics that you would like us to present in the future. Your feedback is important to us, and your specific responses will be shared with the Northeast HERS Professional Development Committee so that we can improve our webinars. You can find more information or register for upcoming mentorship program or HERS Radar trainings on the links that are provided here on the slide. Please feel free to follow us on the social media if you want to hear about any other webinars or events that we may have. And please keep an eye out for any upcoming webinars by visiting the anyhers.org webinar page and look for our webinar emails. So thank you, everyone. Have a great day.
Thank you so much.